plane that we are allowed to add and subtract with one another. Then we looked at object B. Object B, why? Because the ask there at object B, at question A, what is the force that A exerts on B? What is the force that A exerts on B? That's why we look at that one, at object B. We wrote that down, and that's the only thing we have, because we do not have the force, that's the question, and we do not have the acceleration. So we left it there. Then we said, okay, let's look at A first. A, F net is equal to m times A, Newton's second law. We choose to the right to be positive because the object is being pushed to the right. So the force to the right is F, and then the force to the left is the force that B exerts on A is equal to m times A. I'm going to zoom in there. Force F is 20. So I say 20 minus the force that B exerts on A. The mass of A is 6 kilograms. So I say 6 times the acceleration. Again, I have two variables, two things that I do not have, two unknowns. And here I have two unknowns, two unknowns, two unknowns. But according to Newton's third law, the force that A exerts on B is equal to the force that B exerts on A. So this thing here and this thing here is the same thing. So if I rearrange this formula and I get the force of B on A is equal to 20 minus 6A, then I have this thing and this thing equal to one another. Yes? Simultaneous solving of equations, or what do you call it in mathematics? Something like that. So I'm going to say let this be 1, let this be 2, and then I'm going to say let 1 be equal to 2. Why can I say that? Because according to Newton's third law, the force that A exerts on B is equal to the force that B exerts on A. Yes? No, I'm just writing this down for you, for when you study, that you know what. And that was your second question. Right, so we have 4A is equal to 20 minus 6A. Okay, so we have 10A is equal to 20, and thus the acceleration is 2 meters per second squared. But that was not the question. The question wasn't what is the acceleration. The question is what is the force that A exerts on B. So now I'm going to take this equation and I'm going to put the acceleration into that equation. So I'm going to say, okay, and I'm writing this next to one another because I don't have a lot of space. I'm going to say the force that A exerts on B is 4 times 2, which is 8 Newton. And that is to the right. Is it just Rory that's absent today? Is she at athletics? Alright, then they ask a question B. What is the force that B exerts on A? What will that be, Tato? 8 Newton. Exactly the same force. But now it's going to be, so this is question, that is question A, this is question B. It's going to be 8 Newton. But this time it's going to be to the left because it's in the opposite direction. If this one is to the right, then this one is to the left. Yes? Alright. Next question. And this question is a good 2-3 marks at the end of a question for theory, or it will be asked as a multiple choice question. Okay, they say there. 2 trolleys are pushed in opposite directions by expanding spring. Which trolley will accelerate faster? So you see there we have the 2 kilogram and the 4 kilogram. Okay, so we have, So we have two trolleys. The one is heavier than the other one. And the question now is which one will accelerate faster? Kali, which one? So you think the heavier one will accelerate faster? The lighter one accelerates. Why? Because according to Newton's second law, acceleration is inversely proportional to the mass of the object. Meaning, the lighter the object, the faster it will accelerate. Yes?
So it says the weight equals both 2 kg. This one doesn't have the speed also. That doesn't have the speed, so it's a bit faster.
It's not to be 100% accurate because of friction. The same. Why is it the same? Because according to Newton's third law, the force that A exits from B will be the same B as B on A. You with me? Right. So when they ask a question like this, they ask which one will accelerate faster. You hear acceleration, hope you think. Go for it. When a net force object, the object will accelerate the acceleration is to the force, the mass of the object. Well done. Alright, so when they say this, immediately you write down a formula. You get a mark for actually writing down that. To referring to a formula that is on your data sheet. Now, they ask, so did you write this down? Now, they ask, no you didn't. They ask accelerate. So I'm going to rearrange this formula so that I have acceleration as the object or the topic or whatever of this, the subject of this formula. Then I have, sorry, I don't want to say that, is equal to F net over mass. Okay, so we see the acceleration is dependent on two things. It's dependent on the net force and on the mass of the object. Now, we just saw that if the mass were kept constant, we saw that the acceleration was the same. Why? Because the net force is the same. I explained it. I said the net force is same for both. Why? Because according to Newton's third law, the force that 2 exerts on A is equal to the force that 4 exerts on 2. So, in this question specifically, because it's the same force acting on both of them, the force will not influence the acceleration in such a big way. Because it's the same for both. That's not the reason why they have different acceleration. The reason why they have a different acceleration is because of the mass. Okay, we see from this formula, we see that acceleration is inversely proportional to the mass. That is also in Newton's second law. That means that the smaller mass will accelerate faster. Yes? Okay, so this question will count 3 marks. For referring to a formula, for saying what is kept constant, and then for coming to a conclusion. Right. Then here we should practice the different free body diagrams, but I feel like we've practiced that a lot. I just want to recap one. Again, let's just recap this one. Okay, here you see the object is stationary, meaning it's at rest, meaning what formula, Niakalo? Whose law? Newton's first law. And that says what?
A body will persist at its state of rest or at a constant velocity unless non-zero resultant excited.
Wow. Well done. All right. So the net force is equal to 0, basically. What did I say? What's the chances of you having to say Newton's laws in a test? 100%. So Niakolo already has 2 marks and Hope almost has 2 marks. Remember, a definition is 2 or 0. So it's right or wrong? Let's say you say, when a net force acts on an object, the object will accelerate in the direction of the force instead of the net force. I'll give you the mark. But if you say the acceleration is directly proportional to the mass, that's wrong. Wrong. Remember, definitions must count at least 30% of the test. At least. I asked it a bit more. So you can almost get 40% by just knowing your definitions. Just definitions, 40%. Other way around, if you don't know your definitions, the maximum you can get is 60%. And let's be honest, will you get 100% for the calculations? Not so much. So go study your definitions, all of them, from vectors at the beginning all the way through. In each question, there's at least one definition, sometimes 2 definitions. Like question 2, somewhere in between 2 definitions. Yes, Moao?
What if we replace the words?
Like what?
For example, Newton's first law, body will persist. Instead of saying persist, we say continue.
Same. Synonym.
First question.
All right.
Sorry,
First question.
no, but like you say not one. It's a class discussion.
No, it's not a class discussion, it's your question. All right. So here if we look at this object, the object is at rest. The object is stationary at rest. So we have gravitational force towards the center of the earth. Normal force perpendicular to the surface. Static friction in the opposite direction of in the opposite direction of, not motion, of tendency of motion, parallel to the incline or parallel to the surface. Yes?
You see static.
Static there is parallel to the incline. And if this thing was not stationary, it would be sliding down. So it's in the opposite direction of, what's that word that I just said? The tendency of motion. Okay. Now remember, you're not going to leave it there. You're going to split it up into its perpendicular components. What are you going to split up? These two are already at 90 degrees. So you don't want to split that up. You're going to split up FG. You put your ruler there. You put your ruler there. And you draw dotted lines. Then you put your ruler on the normal force. And you elongate it there. Then you put in arrows. Down and to the left. Arrows. And you label them. You know we are here. as the angle that we have on our inclined plane. We proved that already in the previous chapter. Okay, so I'm just going to be lazy. I'm going to call this perpendicular and parallel. And if this angle here is theta, then this angle there is theta. Remember that.
See,
The reason why it's parallel is it not
It's parallel to the incline.
on the ink?
Yeah.
That's what you're focusing on.
Yes. Right, Retabile, how do you calculate FG parallel again? It is sin. It's FG sin of theta. So FG perpendicular is thus FG cos of theta. And really, how do we calculate FG again? And what is G? Wait. Do you remember that? Yes, we've done that now a couple of times.
so when
Yes. I think you're learning a valuable lesson here, is to think before you ask. Alright, please go to question 16. Page 16, sorry. Page 16. Alright, it says there, and now this comes from a past paper. It says, in the diagram below, a 2 kilogram block is connected to a 1 kilogram block by means of a light inextensible string. Inextensible means it can't pull out, so it's not stretchy, and your rope will always be inextensible and will always be light, meaning we don't look at its mass. Sorry, the blocks are pulled up an incline which forms an angle of 28. The sides of the block that touch the incline plane have the same area. The reason why they say that means that they will have the same coefficient of friction. Okay. The kinetic frictional force on the 1 kilogram block and the inclined plane is 4, while between the 2 kilogram is 8. Now they ask, draw a free body diagram and show all the forces that are exerted on the 1 kilogram block. And you can see it counts 5 marks. 5 marks tells you 5 forces. It's 4 marks, 4 forces. 3 marks, 3 forces. So that's your clue. Okay, so you have space on the next page. This is question A. Okay, where are we? Wow. Please give me forces on the 1 kilogram block. Yes, and what else? No. Opposite direction is there. It's not there. Yes. Yes? There's applied force, yes. Say again. Yes. There's 5, it counts 5 marks. In the question, read just below the diagram. Frictional force. Where is that? No, if it's moving to the right, then friction is to the left. Okay. Now, I said you are special. But, and, or. When they ask for this, for 5 marks, so they ask it as part of the question getting marks, then you're going to leave it just like this. Okay, so in a test or an exam, when they ask it for 5 marks, you're going to leave it just like this. For yourself, on the side, you are going to draw a free body diagram for both, where you're going to split it up and where you're going to highlight. So the part where they ask it for marks, you do not highlight, you do not split it up into components. You do that for yourself on the side. Okay, so we have the 2 kilogram, we have the 1 kilogram. Okay, why am I drawing it 2 and 1? Because that's the order in which it is shown in the picture. Okay, so 2 and 1. The 1 we've already done now, so this is going to be easy. Normal force, applied force, gravity, tension, friction. And I'm going to split it up into its perpendicular components, parallel and perpendicular. Yes? So it's the same as this one. The only thing I did is I split it up into its components. Zara, for the 2 kilogram, give me the forces acting there, please. And? Away? Where? Left or right? Yes, to the right. Where? Oh, and this applied force, Zara, isn't that also, shouldn't that be there? No, because, I'm going to come back in a moment, because that 30, if that was someone's hand, is not touching the 2 kilogram. It's touching the 1 kilogram, that touches the rope, that touches the 2 kilogram. So we already have the rope, the tension there. Okay, so from there, you're going to split it up into its perpendicular components. You have a perpendicular and parallel. And then you're going to highlight the forces that are in the same plane that you're allowed to add and subtract to one another. Now I have highlighted 7 yellow forces, 7 horizontal forces. Sebabatsu, why is this up and down a different color than this up and down? The masses aren't the same, they are 2 different objects. Okay, so if this one is being pulled up, then this one will not necessarily go up. And are you done with the practical?
I was just about to.
Okay, and there's something else that I say. Blah, blah, blah. Ona, is this FK the same as this FK? Same size, magnitude? Sure. If this is 10, then this is 10. No, because it's different masses, they have different tensions. Okay? Not tensions, frictions. So these 2 FKs are not the same. These 2 FGs are not the same. These 2 normal forces are not the same. What is the same is the 2 tensions are the same. Why? Because it's the same rope. It's one rope. Okay, so same rope there, same rope, same tension. It's just in opposite directions. Okay, now they ask you for 6 marks. 6 marks tells you definitely more than one calculation. calculate the magnitude, the size of the tension in the rope. Okay, so we've just said this tension and this tension is exactly the same. So you can choose, am I going to look at the 2 kilogram or am I going to look at the 1 kilogram? Okay, and Tando, which one do you want to look at?
2.
Why?
Because it comes first.
Say again?
It's first.
Okay, it's first. In my head, I would think that it looks easier. The other one has more things going on. Okay, so in my head, I say, right, I am going to look at the 2 kilograms. So you tell the person marking, my choice is to look at the 2 kilogram. Now, something that I forgot to write there when I copied it is the whole system accelerates up the incline. So it accelerates up the incline. Yes. For the practical, it's fine.
If we just have to do something. But the test is different.
Right. So I'm not giving you the acceleration. I'm just telling you it is accelerating up the incline. Okay. Right. So if it accelerates, it's Newton's second law. Bukamuso, please go for Newton's second law in words.
When a net force into the mass of gravity, the object accelerates to the direction of the force. Acceleration is directly proportional to the force and inversely proportional to the mass.
Of the object. Wait. Well done. Right, so we said the object is accelerating up the incline. So for that reason, we are looking at the yellow forces. It's accelerating up, so you must choose to the right to be positive. You need to indicate that, show that. Alright, so I'm looking at the yellow forces there. So I have T minus Fk minus Fg parallel is equal to M times A. Okay. Let's check. T was the question. Calculate it, so I don't have that. The frictional force, they told me the frictional force for the 2 kilogram block is 8 newtons. So I have minus 8. Fg parallel, we just said Fg parallel, it's Fg sin of theta. And how do we calculate Fg again? It's mass times 9.8. So the mass is 2 times 9.8 times the sin of, I think it's 28 degrees. 28 degrees. Okay, so you can see you do not need to show these formulas. You can just go substitute them, just go use them. Right, the mass is 2. But I do not have the acceleration. Can I just say the acceleration is 0? No, because I tell you it's accelerating up the incline. So no, the acceleration is not 0. Can I say it's 9.8? No, I do not know what it is. I can't fill in anything. So times A. I put the A in brackets, otherwise my A looks like a 9. So I stop there. Now what? Kutlano? I have 2 unknowns, A and T. What am I going to calculate? I think this will be the 3rd or 4th time that we do the same pattern. Say it. Yes, simultaneous solving of equations. All right, because I have two objects and I have two unknowns for both objects. So when you get something like this and it counts 6 marks, you can somehow know you're going to have to do simultaneous substitution. Yes? Okay. Let's look at the 1 kilogram. Now I'm going to do it next to one another to save space. In a test or in an exam, please write it underneath one another. Pukamuso, focus. Alright. Again, you start with the same formula. Don't think you've used this formula, now it's finished, you can't use it again. Same formula because the object is also accelerating. I'm still looking at the yellow forces and still to the right is positive. If one object you choose to the right to be positive, then the other one must also be positive to the right. You can't change it halfway. For that one, I have F minus Fk minus T minus Fg parallel is equal to M times A. Please make sure you understand, why do I add something, why do I subtract something? Ask if you do not know. Okay, I'm going to zoom in here. The applied force, they said, was 30 newtons. So that's 30. The frictional force, I think they said it's 4. The tension, we don't know. How do we calculate Fg parallel again? It's Fg sin of theta. How do we calculate Fg? It's mass times 9.8. So I'm going to say 1 times 9.8 times the sin of 28. The mass is 1, the acceleration. Okay. So what I'm going to do now is I am going to simplify this here. So that I get T is equal to blah, 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 blah. And on this side, I'm going to get T is equal to blah, 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 blah. So that I can put the two things equal to one another. Okay? So I have T is equal to... Yes. No, not necessarily. Depends which direction you choose to be positive. Because we chose to the right to be positive, gravity is to the left and to the left, so that's why it's negative. If we chose to the left to be positive, then it will be positive and positive. Sharp.
No, is it necessary to fill in the small ones?
No.
Okay, so just the big ones.
Mm-hmm.
Okay.
Thank you. Yes, yeah? What do you get? T is equal to what?
17.20.
That's all. Plus 2a. I'm going to say let this be 1. Remember, in a test or an exam, you write this underneath one another. Ne? Yes.
Also write it because negative 1.
Is negative 1 the same as 17.2? That's question number 4, Khali. No, Khali, it's not correct. This is T, right? It's fine. I'm going to leave it there. Okay, wait, just Courtney, let me just quickly explain to him. Then this is negative 8 and this is negative blah, 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 blah. You're going to take it to the other side. Then you get positive and positive. Then you add them together. Chop.
You don't put the in bracket.
Right, on the other side, Seppo, what do you get? T is equal to what? Sorry, I didn't listen. Say again. 21.40. I get 21. Did you say 30 minus 4 minus that business? And you got? Alright, so 21.40, and then remember this t was negative, so basically we took the t to the other side. We typed in that, minus that, and we need to take that 1a to this side, so we have minus a. And I'm going to make that 2. Okay, so I have 1 and 2, and they are both equal to t. So I'm going to say let 1 be equal to 2. So I have 17.2 plus 2a is equal to 21.40 minus a. Then I'm going to get all the a's on one side, so I'm going to take this to that side, and it becomes 3a. And I'm going to take this 17.2 to that side, and you get 4.2. And you get the acceleration to be 1.4 meters per second squared. But, ladies and gents, that was not the question. The question wasn't what is the acceleration. The question was what is the tension. Going. Gone. The question is what is the magnitude of the tension in the rope. Okay, so I say, all right, now that I have the acceleration, now I can calculate the tension. And it doesn't matter which one I choose, I must still get the same answer. So now you can either go substitute this into 1, or you can go substitute it into 2. Anyone, it doesn't matter. Okay, so I'm going to say the tension is thus 17.2 plus 2 times 1.4. And I get 20 newtons. Yes? Alright, so 6 marks. And I told you, the chances that you'll get a question like this, very big. Very, very, very big. I think your question might be a little bit easier and count 5 marks, if I remember correctly now. Okay. Then the next question says there, the 2 blocks are interchanged. Okay, so we had it like this, and now they're changing the 2 blocks around. Okay, but the same 30 Newton force is now acting on the 2 kilogram block on the inclined plane as shown in the diagram. How will the acceleration on the system change? Only write increase, decrease, or stays the same. What do you think, Cloney? So everything else is the same. The angle is the same. The total mass is the same. The force is the same. Only thing that happened is they changed these 2 blocks. How do you think the acceleration will change? It will stay exactly the same. Because there is the same friction. Let's see what influenced the acceleration. The frictional force stayed the same. The applied force stayed the same. The gravitational force will stay the same. So the acceleration will stay exactly the same. Okay, so what will happen? It will remain the same. Now they ask, how will the tension in the rope change? Increase, decrease, or remains the same? Lucidi? Okay, let's quickly look. Oh, sorry. If you look at this tension here, this tension, it is dependent on the force, the mass, and then the acceleration. But now the mass is not 2 anymore. Now the mass is 1. So what will happen? Okay, so it will definitely change. How will it change? Let's quickly just check. Here, the heavier thing was at the back. Now the lighter thing is at the back. Are you with me? Okay, so imagine it's you and a friend. Let's say you and the friend have different masses. Now, I know I'm not bigger than the city at the moment. So let's imagine we're walking up an incline and the city is struggling and I put a rope on him and I pull him up. Right? There's certain tension in the rope to pull him up. Now I get tired. Now I say, the city, your turn. You pull me up. There will be a difference in the rope. Yes? So now the second time we have the lighter thing at the back. So the tension will be less. Like I said. There the tension will be more. Right. So here you have to use your common sense. And there are questions like this. Not increase, decrease. There are questions like this in your test. Yes?
So like basically what these clenches is, there's two ropes.
We're looking at this rope here.
Yes.